Hello everyone, our senior design project is the automated PCB card backplane failure detection system. The team members for this project is myself, Andrew Smolder, and Eric Warren. Our industrial sponsor is Tim Heisler as well. So as you can see here, we have the automated PCB card backplane failure detection system test bench. It's pretty complex, there's a lot going on here, but this is what it looks like. Looking closer, we can come down here. This is the S90 E32 expansion module, which is the continuity analyzer which we use. As you can see here, we have the ribbon cables hooked up to this that are fed over top, and they go all the way up to the PCB converter, which converts the 65-pin ribbon cables into the usable paddle connectors on these harnesses. As you can see, the harnesses are all fed over top of this test stand, and where they can then just be grabbed and placed into the fixture. So what we have here, this is the self-test fixture, and it has our self-test PCB mounted inside of this. And what this does is this allows an operator to run a self-test diagnostics of this test station to make sure that everything is functioning properly. So in here we have the 165-pin connectors. We can see CN1 up here. This isn't plugged in just yet, but this is a 165-pin connector. We have the 62-pin connectors out here up front, and we have the DB 25-pin connector over here on the left. So next we're going to run a self-test diagnostics on this test stand, and Eric is going to plug in the remaining connector just to show you guys how it works. So you just line up the connector, and then you can slide it right into the self-test fixture. Should just snap right in. So next we can come over here to the test stand PC, where we can run the cable scan executable program. Now this is what the operator will use to run a self-test diagnostics on this test stand. What they would do first is come in here and select the harness type, which is self-test. Then they would select the backplane part, which is the self-test PCB backplane. And then once they select this, they're able to click Run Test. And then once the Run Test button is hit, it'll automatically load the program into test write, and it will execute the program and run a self-test diagnostics on this whole test stand. And when this is finished, there will be a little pop-up saying that it passed or failed. If it failed, it will show you all the test points that failed. If it passed, that's good. Regardless of the state of pass or failure, the results will be printed off on a local printer here, and they will also be stored to an open source database management system called MySQL. So these tests usually take a little while to run, not too much, but it should be done here any second. Alright, so it flashed, test passed. A little pop-up says cable scan test has passed, click continue to finish. So that works, and then we'll come over here to MySQL, and if we refresh this, now this is the open source database management system. If we refresh it and we scroll all the way down to the bottom, we should see that our self-test PCB backplane passed. Here's the date, and here is the time, and the total number of errors is this column right here, and there's 0, so that's all good. And that is our senior design project. Hope you enjoyed it. Thank you.